thanks for the introduction. Hi, everybody. So today I'm going to talk about patterns we observe and about the fascinating journey we had the last 3 years with the upcoming revolution. So we all went from entering prompts to write some simple scripts up to working with coding agents, and we are 100% convinced that we are already in the intelligence explosion scenario, and that we not only need to build agents by ourselves, but that we need to build agents and orchestrate agents that build and orchestrate agents that build and orchestrate agents that build and orchestrate agents. I really could talk a lot about this recurring pattern, not only because it's an interesting meta theme, but it also could fill up the entire talk without even trying. So this is roughly our journey. I don't go too deep into it. I'm pretty sure everybody of you has had a similar journey, starting with Copilot, using Cursor a lot. Then as soon as the coding agent and the CLI came out, we switched over to them, and pretty soon experienced that managing them in parallel is a nice way to work with them, because I was a little bit tired waiting for the finishing of one, and I could have the others working on different tasks. And that pretty much grew into a pattern where I wanted to organize even more of them, and that's what we're going to talk about today. When starting with the proposal for the talk, the landscape with the coding agent was a little bit different. So just to give another pattern from the self-similarity, so 3 years, now the last 3 months, and what we observed alone in the last 3 months and changing the daily behavior of working with the coding agent was the upcoming new models, starting with GPT-5, Opus 4.1, and yeah, GPT-5 Codex was a little bit game-changing. So before we were fans of Claude Code and heavily using Claude Code on a daily basis, and with the GPT-5 Codex we switched, and since, like, I don't know, 3 or 4 weeks, Codex CLI is the main tool we're working with. Besides this, so we are coming from a data background, and we run data pipelines, we run crawlers and bots, collecting data from the web. And what we wanted to combine is the idea, how do the coding agents work in the inner? And so we wipe-coded an agent proxy to have the coding agents run through the proxy so that we can observe the communication with the API. And yeah, this was one of the projects in the last month. The other is, so if you have one agent in a CLI or in a shell and another one, and maybe at some point 4 or 5 or more, you want to have a tool to manage them all. And that's our agent squad. And realizing that you are working on a prompt engineering level, a context engineering level, we wanted to check how are others doing this. And so we started coding and extracting data from GitHub. That's some aspect I'm going to show you. This is one of the most general patterns we see. So very important is the meter chart, which shows the doubling of the length of coding tasks right now every 6 to 7 months. And what we think is that we are still not convergent, but the speed of the acceleration is increasing. So still acceleration of acceleration. And this is the one side, and we experience when working with the agent. So sometimes we give them a task, and 10 minutes later it's done, and it's perfectly done. Sometimes after 5-minute failure, sometimes 30 minutes work works really good. And yeah, of course, we need a human in the loop to not only judge the results and go into the a specification, go into the review of the results and the architecture, but to orchestrate them at the moment. But what we also observe is with the upcoming tools and the MCP and the skills that these agents are able to choose tools by themselves, that they are able to communicate with others by themselves, and that is a pattern we see, that we can employ them in parallel, and that the agents are more and more able to work out stuff by themselves. As this is recorded for YouTube, just a quick poll. The sample size of the crowd, I would roughly estimate about 200 to 300 people here. How many of you are using coding agents in daily life? Yeah, that's 80 or 90%. Who's using Claude Code? Half of it. Who's using Codex? Oh, that's only like 5%. And who's using other coding agents? Half of it. Okay, cool, interesting, nice. And who of you is using AGENTS.md? Half of the crowd, perfect, cool. So then I don't need to dive too much into it. So AGENTS.md is not only like rules on how to set up a project and how to achieve stuff and coding style and standards, but it's also a place for memory for the agent. So the agent can put learnings into it, what to do and what not to do. And the question is, how is it organized, and are there levels of it? Because it's not only one file in the root of the project, but you can place AGENTS.md on different levels, and you can organize the code base, the components, the agents you're building, the tools, and the knowledge. And this is very similar to the skills paradigm we talk in a minute. And you can have so what we are doing is we are not only using Claude Codex, but also Claude in parallel. And the question is, how do you share rules between them? And it's one thing is you can add AGENTS.md in the Claude.md, so he knows where to look it up, or you just symlink to the same rule file. And from the standards, it's just traversing the history, the file directory to the parent directory, and it's taking all the rules it finds up the directory. So, what are the levels to influence the behavior and the results of coding agents? First and foremost, the system prompt. So there's this, Andre Karpathy called it system prompt learning. So through the change of the system prompt, we can change the behavior. We can change which tools it uses and how it uses and so on. Then we have the AGENTS.md we talked about. It's like a rule, like a skill set, like a memory. And then, of course, we have the most volatile area, like the prompts. And the question is what to improve and what to engineer to improve the results and the behavior. And of course we can change the system prompts, but with every new release, nearly every day, there might be new tools, and the system prompt we evolved, that we changed, doesn't work anymore. So this is quite a tough situation. And the prompt, of course, yeah, we can engineer our prompt skills, but we need to somehow save and have templates and use the templates. Though there's in between the place for a rule, for the skill set, and for the memory. And the AGENTS.md are quite a good place, and that's where what we experience on a daily basis. If we maintain this AGENTS.md, we are able to give the coding agents the ability to learn and to adapt the behavior to projects and to situations. And yeah, we all know this skills pattern. And yeah, this is what we see with AGENTS.md, especially when we grow a hierarchy of these rules, and we give every component, every agent we have in our stack, or every script, we give them an AGENT.md, and then the decoding agents know how to handle and how to use it. And the question is, how do we build up the AGENTS.md? And then it comes to meta prompting, because these agents are really smart. And whenever you encounter a problem while running through some tasks, you can tell them, oh, please don't do this again, and adjust your rules to not do this again in the future when you face the same situation. So this is one. And the other is if you have finished like a session and you developed a component with all the tests and it's running and it's fine, then you can ask it, please take lessons learned out of your sessions, make reflect on your rule set, make 5 suggestions how to improve, what to expect, and then but wait for my approval. And then you can tell him, yeah, rule 1 sounds nice, let's incorporate that, round 4 is nice, let's do this. And that's how we maintain and develop the rule set. And that's how the agents learn, can learn. So, talking about the skill pattern. So this is a really, really nice abstraction from the Anthropic guys. And that's something we are used to do on a daily basis, even before it was called skills. And it is asking the coding agent to build a script or to build a tool. And coming from the data background and being data analysts, we wanted a self-similar and self-reflecting tool. And we asked it, please scan your home directory because the sessions are saved. And I'm not sure whether you know this, but you can resume sessions and you can fork sessions. And the dialog, all your prompts and the tool use and so on reside in the home directory. And we ask Codex to build up a script to collect and analyze these traces and to collect tool usage and token usage and the runtime. So not only you can ingest and reflect, did you do something good or not too good, but you can collect data. So if you want on a later point, have some better decision grounding for orchestrating more of them, then you need some abstraction, data-driven approach, and this is how we build a skill. The skill is called analytical tools. So, what we heard a lot today is these projects drift, and the #1 approach is testing, 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 and these agents are really capable of inventing tests. And what we also encountered is if you have the agent using the tools, CLIs, interactive shells like you do, it's even better to fix errors you encounter and have them find these errors. And what you also see is these models want to fulfill the task, and they do and try very hard, they work around, and they fake tests, and that's something we don't want, so we tell them a lot of time, and that's rule #1 in AGENTS.md for testing. No fake, no mock, no stub. You are a coding agent, you are able to code, please code real code, no fakes. Next thing really important with coding agents or with LLM in general is context engineering. So we've seen in the beginning, the first of a message to the LLM is a system prompt, then the rules, and then some user messages with answers. Yeah? And this is called context. And depending on how the context and the chain of thought went, you might get good answers or not too good answers. And everybody noticed is when the context fills or when you walk the wrong paths, at some moment the intelligence of these agents degrades like I want to swear and throw them out of the window. And the solution, there are some solutions. So one solution is editing the context. So some of you might already know, but when working in the shell, you can double escape, and then you can edit the history. And if you prompt for the next solution and the next answer, and you think, oh, that's not how I meant it, just escape, escape, edit it. And you can just go up the chain of prompts, and you can edit back the whole context. And that's how you, at the moment, do context engineering by yourself. The other thing is, so these models have this compact mode, compression of the context. So when the context is full, it has auto compression, for example, but it's intransparent. So we don't know what the model is doing, how the coding agent is doing, and how it summarized the context. So what we need to do is, or what we tend to do is ask it to summarize by ourselves, then check the summarization, and hand it over to the next agent. So this works quite well. Coming to the second half of our talk, experiments with multi-agent orchestration and the paradigm of mixture of coding agents. We gave them the skill to manage other coding agents via Tmux shell. So it's an agent.md, and we tell the Codex agent, use this to spawn another coding agents, spawn some Claude, spawn some Codex, and using this you can spawn a lot of codings, as much as you want. The experiment we do is ask them to build an agent, and so we have the coding agents, really, really important building blocks on our way to AGI, and then the others are search and deep research agents. As yeah, everybody of us could come up with a good idea, but look to the outside, the ideas are all there, people are inventing a lot of stuff, and it's impossible to gather all the ideas and reflect and evaluate. So let's have the agents do the work for us. First experiment, Codex versus Claude, like it comes out of the installation, only one prompt, one shot. Please build a search agent is in the Strands agent framework, which is a nice framework from Amazon. And let's see how it plays out. So we deployed like 20 agents and used our metrics tool to collect the statistics. And we see, okay, nice experience. Every agent finds a solution. So this is new. So remembering the meter chart, so when we remember 3 years, 2 years, 1 year ago, that wasn't possible. Right now, they run for about 20 or 30 minutes and come back with a search agent able to search via Brave, via Google, via Tafili for information in the internet, just with a single, simple prompt. And in our race, Codex had a little edge for Claude, but this is maybe because we are more used right now to work with Codex, and the prompt was primed a little bit. So that's how a typical solution looks like. Many of you might have seen similar approaches. It iterates through the tasks, it's planning the tasks of searching, and then summarizing and delivering the answer. And if you prompt it right, it can deliver a structured answer, which you can use to score and compare the model. The question is, do agents rule help when tasking the agents to build agents? And it turns out they do. And what we've done here is just a simple AGENTS.md file with rules, like where to find configuration, where to find the key. So that's something we observed, like the agents not knowing where, it's looking everywhere, and it's spending tokens for nothing. Yeah? And also you might want to have some patterns you observed from yourself, which are nice, and that's how you specify, and you see, okay, specifying some rules helps in improving the model score. But what you also see, and that was a little bit surprising, is it increases token use. So one might have thought guiding the model to better solutions will help in saving costs and runtime and tokens and tool use, but it actually increased it. And that's because it knows the possibilities of the framework and the tools there, and was able to come up with much, much better solutions. Next thing in the orchestration pattern thing is a pattern we use by ourselves, and here we spun up the experiment is having an arena mode and an cooperation mode. So running an experiment with 20 agents in parallel already is like a kind of an arena, because you can pick up the best solutions from the 20. But having the agents decide by themselves is also enhancing. And you can have a second iteration where you give the one agent the results of the other, and the other the results of the one. And you can ask them, please reflect about the solution, what's better than yours, what could be helpful in improvement. And you can give them the chance to improve and refine and reflect their own solution. And it turns out it's really helpful Yeah? Not only because of the refinement of the chance to spend more test time to improve the solution, but also when having different agents. For example, the Sonnet model behaves different than the Codex model, and the information and the ideas they come up are different. And models who get the chance to see other good solutions are able to reflect and integrate this in their approach. And you see that the score is increasing, and the refinement budget is much, much lower than the building up budget, because it just needs to adapt some of the components and don't need to build up the whole system. That was a funny observation. One of the agents, though the prompt was primed with the arena example and how you can look up the solution of the other and use it to improve your own solution. And one came up with an arena solution for the search agent in itself. So this was like another self-reflecting pattern, and it helped really, really in the end in the results. Yeah, last part of the talk is how we use our GitHub tool and skill. So far we've seen the metrics and the analytics skill for coding agents. We've seen the orchestration skill, how to orchestrate the others. And then is the question how to come up with good solutions. And it might be interesting for the agent not to only search via internet search, but also to look at good solutions from GitHub. And the first thing, with the hammer in the hand, everything looked like a nail, being data guys and crawler and scraper guys. We crawled and scraped the GitHub API, and we extracted Agents.md, Claude MDs, READMEs, and so on. And we made some statistic, and we see like the trends. And you see like the moment when Claude picked up, and then like 4 or 6 weeks ago when the other agents, Agents.md was published in May, I think, and that's where you see like an increase. And it's an unfair advantage because every other agent is using Agents.md, and Claude.md is only used by Claude. Skills are exploding right now. So you see the skills per project, but you see like an average 5 or 6 skills per project, though the number is much, much higher than you see here. Then we use the intelligence of the models to classify these files. So rules DAP, or kind of rules, kind of project, product lifecycle, system lifecycle, Gen AI focus, agentic level, and so on. And then we try to extract patterns we observe and to find good solutions. Having a vector database at our hands, so we've put on all the Agents.md in it, and we ask our agent to retrieve and re-rank good solutions depending on the question. And we employed some metadata filters, so it is able to filter recent projects and filter specific Agents.md, or like reflecting on the kind of the repo and so on. And interestingly, with the question, create an Agent.md, so it has the ability to reflect on some of the results, it came up with really, really good solutions. And it improved the results as well. And if you've been into meta prompting, you'll see that the prompt these agents come up, they are better than the prompts we come up. And if they have the chance to look at other good solutions, it improves the quality even more. Yeah, and that's it, finally. So the best agent found every information about me, yeah, luckily. So there isn't too much about me on the internet, and it's a hard task, I can tell you. But it managed, and yeah. So if you are interested in getting to know more about this, or in the scripts and the agency, just contact me, let's get in touch, let's talk and chat about it. And then I can send you some of this and even give you access to our Q&A assistant. Thank you.
Wow.